the in the one layer, that application layer. In the application layer, we have seen how the application is deployed, so how it is getting scheduled, how it is getting an interface, and who is assigning the IP address for that interface. Then we have the kubelet cryo and all these things forming the application layer entities, or you can say application layer components, so that the application is up and running. And the one more thing to note at the application layer is that when you look into the application, this application has got an IP address. So using this IP address, I can able to communicate to this application. Okay. So I can able to communicate to this application using this this IP address, but this application is this communication is restricted to the internal cluster environment. So I cannot do it from the external world. So this is restricted to the internal environment. So internally, from the internal to the cluster, I can able to communicate to the application. So as of our lab environment is concerned, we can see this is our lab environment. Like, take a screenshot of this. Okay. So we are accessing the lab, like we are accessing the cluster, so from the workstation, which is external to the cluster environment. So when I want to communicate to the application using the IP address assigned to that application, so I need to get inside this cluster. So I need to be in any one of these missions. Like I have 3 missions inside the cluster. So these missions are acting as a master as well as worker. So I should be in any one of these missions to access that. There's a meaning of internal, like internal to the cluster. So I should be in any one of this mission inside this, and I have to communicate to the application using this IP address. So I can do like so you can we have seen during the class that so we'll be using the debug command to get into that node. We'll be using OC debug node. I can say master 1. So I'm getting into this node. So here inside from this node, I can do a curl. I can use this IP address, and always I have to use a port. It is very important. Whenever you are accessing the containers, you have to use a port. So you have to remember this model. Now you can see I can communicate to this. You can see the reply from there. So I can get into the master 1, or even I can get to the master 2. From any node I can able to communicate. So I can get to the master node. From there also I can reach this application. Then I can get into this one. I can curl this one and reach the application. If I do a curl from here, you can see the same. So this application is designed to produce the IP address of the application. So whatever the IP address it has assigned, you can see the same IP address as a reply. So as a output to that application, whenever I hit that application, you will see that IP address of that application is shown as a reply to me. So here I can reach this application into the cluster, but when I want to communicate from the workstation, so I cannot reach this application from the workstation because as of the lab arrangement, so this workstation is outside of the cluster, so it's not in a part of the cluster. The workstation is a mission like we are able to access the cluster through the command lines. When I use the OC command, I can able to access the applications. But when I want to do a direct curl, so when I use this curl commands, so this will not work. This is like directly accessing the application outside the network. So this is not an OC command. This is like a curl command. If I use direct curl and try to access it, I won't be able to access it. The reason is the network is different, as well as I don't have a path or means to access that application. So I cannot reach that one outside the cluster from the workstation mission. But when I get into the cluster, when I get into the master node or like master 1 or master 2, from there I can able to communicate this. So using this IP address, this is the meaning of internal communication. So this the application layer, we will be able to, using the direct pod IP address, I can able to communicate to the application internally. And one more thing we have to remember, we have to remember a model over here. So when it comes to the multi-container deployment, so we are not saying the multi-container deployment in detail, but anyhow, so it is always advised to, if you have a similar container, it's always advised to place a container create that container as a separate pod. So don't create a similar container, don't place a similar container inside the pod. So you can place it, so nothing will restrict you from placing it inside the pod, but this is not a recommended practice. Always it's recommended to. So if you have dissimilar containers, which is not similar in nature, so in that case you can go for multi-container deployment. So you can go for like this. You have some main container, you have a supporting container, then you can place them inside a single pod. So that will be reasonable. So don't place a similar container in the same pod. Having said that, so this is the model. So where you have a pod has got an IP address. So suppose if I have multiple containers, how to differentiate this container, one container from another? So I want to reach this container specifically, which is inside the pod. How to reach it? Each container will have a port. So when I was deploying the application, the container got a port. So I have to access the container through the port. So this is what a socket is. So we have IP address and the port. The IP address together the port combination, we call that as a socket. So you have to use a socket communication to get to that, reach that container. So whenever we reach any container, we always use the port. So here also you can see I can reach that container only through the port. Even though I have only one container, I can reach that application only through that particular port. So you can see when I get into this mission, when I need to get in the master one or this mission, when I want to reach that one, I have to use the port to reach that container. So this application was exposed in two different ports. Thank you. Well, so I can reach it. I can reach also through the 8443. I can reach it through this port also. But this is secured port. But that's why I'm getting this information. So I can use here -8 to ignore this. Okay, I can use here yes. And you can see that I'm getting the reply. So this is a secure port. So either way, so I have used this 8443 to expose the application if I want to reach that in a secure manner, and or I can use the insecure manner, like I can use this 8080 to reach that application. So I exposed it depending on the user requirement. They can use the different ports. So anyhow, but for the communication, I need to use a port. Even if it is having one single container, I have to mention a port to reach that application. So that you have to remember this model that you reach the container with the socket combination. So anytime you are going to directly communicate to the container, you'll be using that IP address with the port combination. So whatever the port you have exposed that application or you have created that container, so that through that port you'll be reaching that application. So during that deployment time itself, so if you look into the deployment file, so there itself we have defined the port. So this is the deployment file. Here itself we defined the port. So this, through this file I created this deployment. Here I have defined the port. So it's always necessary to define the port. Through the port I have to reach that particular mission. And now we move back to the next layer. So that's all there in the application layer. And I'll move back to the next layer, the service layer. So service layer is essential for many reasons. One of the main reasons for we are going for a service layer is the load balancing. So I need to do a load balance when I scale the application. So for example, this is the scenario, like let me build the scenario which we have in the lab. So let us consider this is the cluster. Inside the cluster, I am having the worker nodes. Let's say these are the worker nodes which I am having. in our case we have 3 worker nodes, which is the master, master 1, then we have master 2, okay, and I am creating a project. So inside the project I created a deployment. So this is the project which I have created. In the project I have created a deployment, which is the project name was my demo 4. Inside that I created a deployment. So the deployment was, so I created a deployment, and deployment created these things like the deployment created a replica set. The replica set has created a pod. And the pod has created a container. We have a replica set, like that we have a pod. Pod created a container. So this is a container, and whenever you created this, so this pod and container is deployed on the worker node. So this pod and container now gets deployed on the worker node. So say it is deployed on the master 1. So this is fine. For the deployment, I'm able to deploy this, and the deployment will be in the control of this one. So this is fine. So the pod is created in this one. And whenever I create a scaling, whenever I do a scaling, so using the replica set, so multiple pods will be created. So the pod may be created in the same node or may be created on the different nodes. So there is a like the pod is scaled. So here I do have only OC get pod. So here I do have only one pod running. When I do OC edit deployment, when I open the deployment file, deployment name is my app. I open the deployment file and I scroll down to the replicas here. So here I go to this replicas section. So here I change the number. So here I change the replicas to be 3. So I make it 3. So I save the file. So after saving this, immediately you can see, now you can see that 3 applications will be running. You can see now it has started creating container. Now you can see 3 applications are running. So previously it was 1, now it is 3. So I have scaled this application. That's fine. So here I can use this along with this watch command. I can use OC hyphen void to see where that is running. So in this case, it is running in the same master node itself. It's running on the master 1 itself. The 3 application is running on the same node. So here it can see it has got an IP address over there. So when I scaled it, so for the times namesake I consider this is scale. This application is running on different node. Sometimes it may run on the same node. Sometimes it may run on the different node. So for the time's sake, I consider this is running on the different node. Okay, it's running on the master node. Master node. So through the replica set, so what we have done is we have scaled this application twice. So through the replica set, we have scaled it so that through the replica set, I have scaled this application. And once you scaled it, what I have to achieve is I have to achieve a load balance. So one thing, when I scale it, you can see I got 3 different IP addresses. Okay, the IP address is also different. If I scale it 100 times, I will have 100 IP addresses. So that is one. One requirement for me is I need to have a common control unit or common control point or a communication point where I can communicate to one point, and that should redirect my request to the other like application. So instead of using, because I have to remember this 100 different IP address, or I have to keep a track of this 100 different IP address. Maybe sometimes I scale this application to 100 times. When the load is not more, I reduce this to 50. So the other 50 application which was having an IP address will be released back to the network operator will take back that address, and it will assign for some other application. So that is not there. That IP address is not there. So I need to find a way. So I do not want to take care about this one, like whenever I'm scaling, descaling. So I don't want to take care of this one. So I need to have a common point. So my communication point will be that element, not the direct pod. So I can communicate now using this direct pod IP address. I can reach this application, but that I don't want to go for that kind of a model. So that is if I want to do that, that is like I have to use every time I have to keep a track of this, what is live and what IP address is currently in use and what is not in use. So I have to keep a track of that. So I need to create a control point where a control common point where I will communicate to that point, not to the particular pod. So my request will reach that, and this will redirect my request to that pod, even if it is 50 or it is 100. I don't care about that. As a client, I need to access the application. So that is one requirement. I need to have a common point to communicate. That's one requirement. Other requirement is that I should it should do a load balance. So the main point of scaling the application is to do a load balance. Load balance in a sense, sometimes because when there is the demand, I will be scaling the application. The demand grows, the load balancing should happen. So it's not that always one application should serve the client. If I do that, there is no meaning of scaling the application. So there is a requirement for me to have a load balancing element. So that is what the service is doing. So here we come to the concept of service. The service, what it is doing is, first thing, it is a common, you can say common control point, or you can say it's lacking a control point. So where your communication point will be service, not the direct application. That is one. Another requirement for the service is through the like load balancing. So it has to do the load balancing. So that is another requirement of the service. So we are now in this scenario, like we have the application. So we have the replica set. Using the replica set, I have scaled the application. So there is a client sitting here. So who want to, maybe here 4 application, I have 4 different IP addresses. If it is 40, I have 40 different applications. So the client is looking for some common point through which he can communicate to this, or through which he can reach to the pod. So what will be that common point will be here. So that point is the service. Service is doing 2 things. One, it is acting as a common point to the client, so that client needs to need to reach the service, and service will also have an IP address. So that will be constant, because service we are not going to scale it. Service will be one element. Maybe pod will be scaling. So how many number of times you are going to scale it? So here you have 4. If I scale it to 10, the 10 new or 6 new pods which is created additional to this 4, that will also come under this service. Okay. So client will just reach the service. The service is going to redirect the request to the pod. So it will do the load balancing in the round robin fashion. So first the request will go to this pod. The next time the request may reach this pod. Maybe 1 or 2 times it may hit the same pod. But after 2 or 3 times, it may redirect the request to the different pod. So this is what the service element is going to do. Okay. So this is the main purpose of service. So in our scenario, so inside the cluster, so we have a common network point, so which is a service that will take control of this one. So let me now let's for this one. So I scaled this application. Let me say this is the situation. So here I create a service. The service we are creating at the project level. So once we create this service, so this service will be a common control point for communicating. So here you can see that. So these are called the endpoints, the application which you are reaching. So the services we are creating at the project level. So these are called the endpoints, the application which is called endpoint. So in the network terminology, we call this as endpoint. Normally we call this pod, but the network terminology we call this as endpoints. So all this is another end, this one endpoint, this is another endpoint. So all this is called endpoints. Okay, fine. Now how to create this service? So how the service will identify these pods? So which pod should come under this service? How the service is going to identify it? So how we are going to do that? So here we are going to get the help of the label mechanism. So whenever we are creating the pod has got a label. So here you can see, so we have created a pod here. You can get OC get pods. So if you do describe one of the pod, so here I'm describing the my app, and this one going to grep for label. There you can see it has got a label. So this label for this pod we have defined in the definition file. When we are defining that file, so when I define that file, you can see in the file definition itself, in the metadata under the template, I have defined this label. The label is deployment is my app. This is the label. So all the pod you are creating out of this template will have this label. So even if you create it 100 times, all the 100 pod will have this label as a common factor. So as a common thing. So whenever you're using this, because this replica set is going to use this pod template, and the pod template is going to carry this label. So all the pods. So here I have 3 pods. All 3 pods will having the same label because it's commonly defined in the. So if you look at the labels, if you look at the label of other pod, so here I have to use it, this one. You can see this is going to have the same label. So even if you describe the last one, it is going to have the same label. Even if you scale 100 times, it will have the 100 pods will have the same label. So because that is coming through the deployment. In the deployment, we have defined the label. So that it's going to use that as a template. So whenever it's going to use that template, it will carry the same label. So that's fine. So we have the label here, and this label. So once you are going to create a service, so what you will do is you will mention this pod label in the service. There will be one factor called selector component. You can say label selector. In the service, you will mention this label, whatever the label is there in the pod. Maybe it may have 1 or 2 or more than 1 label. So you will mention whatever the label is there in the pod. You will mention that label in the service. So automatically, this service will choose this pod. So even if you scale the pod, it is going to have the same label. Ultimately, the new pod which you are created, that will come under this service. So that will be acting as the endpoint to this service. So this is the mechanism. How it is a very simple mechanism. How you create the service, how you map the service to the pod. So when you use the OC new app command, you don't have to worry about this because the OC new app command automatically map and everything. So it will create a service. The service is ready for you to use. But when you do it manually, so when you in the Kubernetes way, when you do it manually, when you use the declarative file, in that case, you have to look for what is the label. You have to get that label and mention that label inside that service selector. Okay. And the service selector and the service has, we have different types of service. So this is the internal service which you are going to, this service type is called cluster IP service. So we have other types like load balancer, node port, like different types are there. So we are not going to see that. That is basically used for external communication. So we are not going into that. We are going to see the internal way of using the service. That's only one type we can use it an internal way. That is cluster IP type. I'm going to use that type. So here now my job is to create the service. Now in this project, OC get pods. We have the pod. If I do OC get all, they can find the pod deployment replica sets are there. Now my job is to create a service. So I have the service file defined. So here I'm going to have already created that service file. Okay, so here I have the service file. So this is a kind of service. Name of the service, I'm going to say this is my app. You can give me any name. So here this is the service port, and The target port represents the port of the container. Okay. There are two ports you have to mention. So this will be almost same. The service port and the target port. This is a port of the service. Okay. And service will have a port, and the target port represents the port of the container. So for which we are mapping, and we are going to. I named this one as 8080 TCP. This is the name of that port. And similarly, I created for the secured port. So I have exposed the application two different ports. I mentioned that port over here. One is insecure. If I want to use this application in a secured way, I have defined the secured port. And the main important thing to note is the selector. The selector is the deployment. You can see the selector which I am mentioning here. Deployment, the label. So here I have mentioned deployment my app 1. It's my app. Just I would have mentioned this label. So you can check the deployment, the label of the pod. So here you can see this is the label of that pod. The same label I'm mentioning inside that service. This is a service file. Inside this service file, I'm mentioning this same label. You can see the label which is here. I'm mapping this label to this. Okay. So now I'm going to create this service. Using this definition file. So I'm defining the service. So defining the file. So here I'm naming the service as my app, and I'm defining the port. And the last thing to notice, you have to define the type. So there are other types also. Here the one type, the cluster IP type, is for internal communication. So when you want to use the service, as I mentioned before, when you want to communicate the application externally without the route, you can do that using the service. In that case, you have to go for different type of service. So we have service type called load balancer. We can have a service type called node port. So external name. So there are different types of services are available. So here we are not to use that. So we will be using the route 2 for external communication. We don't have to worry about externally communicating using the service. So we are just concerned with the internal one. So we want to see the services acting as a common control point, and also we are going to see the load balancing thing. Now you can see this type is cluster IP. So this is the mostly used for internal communication. The type will be cluster IP. So using that, I'm going to create a service. So initially I don't have any service in this project. If I use the service, I don't have anything. Now I'm going to get the service. So I'm going to say OC create. So the same command, I'm going to point out to the file. So this time I have to point out to this service file. So I'm creating this service. Now you can see the service is created. When you do OC get service, now you can see the service which is created. Now the service has got two ports. So through this port, you can able to reach that application. This port will map to the target port, and you can reach that application. And you can see that it is the type is cluster IP. You can see the cluster IP. The cluster IP is the internal IP generated, and this is also provided by the network operator. So if you just see OC get network, you can look into the configuration file of the network operator / cluster. You can see I can go JSON. So you can see that there is a service network range is defined. So there's a range you are going to get that service IP addresses. The range is defined for that Openshift SDN. The service network range is defined. So this is also defined during the installation process. So when you're doing the installation, you will define the network operator. So that network operator will have the range. So whenever you're creating the service, so this operator will assign that IP address to that service. Whenever you create a service, automatically it will give a IP address. So that using that IP address, you can able to communicate. Now we got a service. So we see get service. Now we want to see the control part. Now we want to see these 2 points, which is the main reason why we are creating the service. We want to see the control nature, and we want to see the load balancing nature of the service. Okay. Now also this is a service also is internal. So the service, you can see this is a private IP. So I'm going to use it as internal communication. Still I cannot communicate from the workstation. I have to get into the node and I have to communicate. So it's because service and the application layer both are internal to the cluster. But remember, using the service, you can do external communication also, but we are not going for that. So that is option. So it's not that service is always used for internal. You can use the service directly to communicate to the external. The Kubernetes point of view, you can do that, but we are restricting the discussion to the internal communication because we are going to use the other layer called route layer to do the external communication. So we have the service here. So we'll check that now. We'll go to the node. We'll get into the internal to the cluster. I'll go to the node. So I can go to any one of the node, master one or something. So I get to the master node. So I do a curl. Now this time I'm going to use this cluster IP. I do a curl. Now I'm going to use the port, which is 8080. I'm going to use the insecure port. So I'm calling. So you can see now my request is getting load balanced. So you can see when I reach for the first time, so it was reaching the pod, which is this one. So you can see that we have 3 different pods. So 43, 42, and 44. My request now goes to the first time when I reach it, it was going to the 43, and then it was 42. For some time it was just maintaining 42. Then after some time, it again load balances to 43. So you can see the load balancing nature. You can see it is reaching the 44. So all 3 pods are involved. So whenever the client reaches, all 3 pods are involved in the serving the client. So at different time the different clients are reaching. So all 3 pods will be redirected. So the service is doing that work. Service is acting as a control point. Now you can see I'm just using only one IP address. So I'm now, even though I do have multiple IP addresses which is there for the pod, I don't worry about that. I just use one IP address which is acting as my one control unit or one control point. And other this, you can see the load balance happening. So this is the reason why I choose this application, because it's going to display you the IP address. Normally, if you take any application, you will see the same result. You will not be able to observe the changes. So that's the reason why I choose this image, because this image specifically designed to just produce the result of the IP address of that application, the container that pod IP address. So you can see that, so that you can, whenever you're reaching the different things. So I'm using the same service or cluster IP. So you can see that the request is redirected to the different pods. The load balancing is happening, and also I can using one IP. I'm just communicating to all the pods. Even if I have 100 pods, all the 100 pods will be under the same service. If you do that, OC describe service. So the service name is my app. If you describe this service, you can able to find the endpoint. So here you can see these are the endpoints. The endpoints are nothing but the pods which are there, which is connected to this service. That are the endpoints. So here, since I have 3 pods, you can see the 3 endpoints here. So with 2 different ports, you can able to communicate. But when you want to communicate 8443, that should be a secure port. You have to use HTTPS. When you can communicate insecurely using the 8080 port. So this is the endpoints. So you can separately view the endpoints also. You can just use OC describe endpoints using this command. You can separately view the endpoints. You can see the endpoints over there. Just as IP address, you can see what are the endpoints and through which port it is exposed. You can see the port name and the port numbers. So separately you can view the endpoints. So the endpoints are this whatever is connected to the service. So these are I described that as an endpoint. Okay. So now we have the service, and this is a service layer. So the main idea behind the service layer is to provide a common control point and as well as the load balancing. So whenever you create a service, you should always remember that. So when you create it manually, so when you use the OCNAP command, we need not worry about the creating the service, because service will be created as a part of that command itself. So you can see that when you use the OCNAP command, deployment will be created, service will be created, image stream will be created. So we need not worry about service, creating the service. But when you create it manually, you have to see the label selectors are matching. So if this label selector is not going to match, this service will not choose this pod. So for example, if the labels are not matching. So for example, here the selection criteria, I have mentioned 2 labels, and in the pod only 1 label is matching, other labels missing in the pod. So in that case, what the service will do, service will not select this pod. So service will be disconnected from this pod. So you have to remember that. So when you're doing troubleshooting, you have to remember this point. So, or when you're doing the manual service mapping, so you have to remember that always the label selector, the label which is mentioned in the pod should be mapped to the labels in the services. So maybe 2 labels, no problem. The 2 labels should be mentioned here. If there is no, like your 1 label is matching, 1 label is missing, then in that case this will not select it. There are other conditions like I may have multiple labels. The pod I have multiple labels, but if this label criteria are matched, then I have no issues. Like here I have mentioned two labels are here. With additional to that, we have other labels also, but I don't care about this. So I want to see whether this label selector which mentioned in the service, if that matches, then it will automatically choose it. So it may be like 1-to-1, like it may be two labels over here, two labels over here, or it may be many. So that is okay. But if one is missing, whatever the label you have mentioned, if that is missing here, then it will not choose that. The service will not choose that pod. You have to remember that criteria. Okay. So this is what the service layer. And now we move back to the last layer of the model, where it is called a route layer. So route layer is basically used for external communication. So you are going to communicate to the pod which is running, the application which is running inside the cluster. So I'm going to communicate to this application external to the cluster. So how this is going to work? First thing, whenever you are creating a cluster, so whenever you're installing a cluster, it's always mandatory to provide an domain name. So the domain name may be like a publicly resolvable domain name, or it may be a domain name which you are going to create for internal purpose. So for internal networking, you can create when you are installing offline way. So your purpose is just to use it internally. The cluster is for just internal purpose. So you are not using it for production. In that case, you can have a public, like normal private DNS domain. So you have to mandatorily provide that domain. So because through that domain only, I can communicate the application from the external world to the from internal to the external. So without that domain, I cannot reach it. In the production side, you have to always give a publicly resolvable DNS address. So that is mandatory. So during installation, you will see you will be providing that input, like publicly resolvable DNS. So that DNS will be the cluster domain. Through that, you are going to reach the application. So so how this is going to work? So internally, I have two different components. So internal to the cluster, I have two different components into the Openshift cluster to do this function. So first component is the router. So router is going to run as a pod. The router is there is a project called Openshift Ingress. So this is a default project. So inside this, there is an Openshift Ingress operator project. Through that operator, there will be an application created here. And this operator, this pod is called a router pod. So router pod will be created. Here router. The router pod will be created. And this router pod will have an inbuilt HA proxy mechanism. So HA proxy is a load balancing mechanism. So that will be underneath this router pod. So HA proxy, which is going to load balance a request. You have one front-end facing server, but at the backend I can have multiple server. My request from the client will be load balancing. The client will see only one server, but at the backend I have multiple server which is serving the client in a round-robin fashion. That's what the HA proxy will do. The same thing happening here. So I am going to create multiple URLs, so which will be at the backside of the router. At the front end, I have only one URL which will be for the client, and client will reach that router. The router is going to redirect the request to the concerned server, also in the case the concerned pod. So this is what the HA proxy mechanism is going to do. So I have this component. So there is Openshift Ingress project. So whatever the DNS name, publicly resolvable DNS name you have provided, so that will be taken as a router's public facing domain or public facing IP. And the backend other side, it will be taking the URL you are creating inside for the application. So to create the URL for the application, so we need to have a DNS. So we have to create a DNS record. So we are going to have a project inside this one. So it is called Openshift DNS project. So Openshift, there's a project called Openshift DNS. So inside this, I have a default DNS which is running. So here will be the DNS pod running inside this project. So work of this DNS, what it will do is whenever you create whenever you created a service, for that service it will create a DNS record. So it will generate a DNS record, And how the DNS record will be generated? The DNS record will be generated in this hierarchy. So like it will be taking the service name, because we can use our own thing, but here it is going to, by default it will use the service name. It will create the record service name hyphen followed by the project name, then followed by the cluster domain. The cluster domain. So this way this will create the DNS record. Or this is one option, or you can create the DNS record manually also using the host name concept. You can use your own host name followed by the cluster domain. So whatever the cluster domain you are having, you mention that cluster domain, and you can create your own DNS record. But if you don't create it, automatically the DNS record will be there. This DNS operator will create the DNS record. Whenever you create the service, it will create a DNS record. So once you expose that DNS record, you get a route through that I am able to reach that application. So this is what the DNS is going to do. So whenever you expose this, so you have the service. Whenever you expose this service, you will get something called a route. A route will be generated. A route will be generated to this service when you expose this service. This is called exposing process. So normally we can do two kinds of things. We can do expose. We can also create. We'll see that create is for secure deployment. Now we are doing insecure. So when you just simply expose the service, you will get a route, and this route will be will have an entry in this router. And what the client will do is, client is going to reach this router. Client will reach this router, and your request will be router. So your flow will be like starts from here. So the client, for example, client reaches this router. So after reaching this router, your request will take this route. So after taking this route, your request go to the service, concerned service, and once it reaches the service will redirect the request to the pod. So this will be the flow of your communication. So this will take this part. Okay. So this will take this part, and we have to create all these things. Now the service is already there. So if you simply expose this service, you will get a route. This route will have a default entry in the router. This router, DNS, and all these things are already there. So we need not do anything. So we just need to expose just one single command. It will do all this work. So just simply if you expose it, you will get a route. The route will have entry in this router, and once it has entry, so whenever as a client you are reaching this router, your request will come here, and then it will reach the route. The route will redirect the request to the service. Here, right there. This is the client. So now the client is reaching. So this is how the flow will happen. Okay. So now we'll observe that how it's going to work. So we'll observe the default components, the networking, the external networking component, the router and the DNS. Then we'll see how to create the route. Creating the route is very simple, but we need to know the flow, how it is happening. We go to the lab. So now, so you can get to this project, OC project, Openshift ingress. So this is a default project available. You can get to this ingress project. So here you can see the pod. So there is a router pod which is there here. You can see the router default, router pod. So for high availability, it's running 3 times. And I will see describe pod. So when you describe the pod, you can see here the router, the router domain. This is the domain. So this is the whatever the public domain you are giving. So whenever creating the, for example, if you are creating the cluster in the AWS, In AWS, we have a mechanism called Route 53. So Route 53, you can purchase it. You can have a DNS, your own DNS entry. So the DNS can be given as a input to this router. So that will be your main domain. So whatever the application you are creating, that will be a subdomain of your main domain. So this is the main domain. So whenever you're expressing the application, so this will be the main domain. So you can call, there are other names to it. You can call this as a cluster domain, or you can call this as a wildcard domain. So this is called a wildcard domain. So this is very crucial, because using this only I'm going to expose the application externally. So that will be the domain of this the router which we have done. And you can see the router is using the HA proxy mechanism. And a router is having some its own certificates and all these things. And this router, this default router is managed from the operator. So there is every critical components will have an operator. So operator for this is running on this project. You can do also get pods -n Openshift ingress. So there is ingress operator. So the ingress operator is running inside this project. So this operator will take care of that router. So ingress operator is over here. So this is going to take care of that router. So many critical component, even if it is a DNS or anything, so that will have an operator. Through that operator, that component is deployed. There's a cluster components is deployed. So next component to look at this DNS component. You can just get OC get pods -m Openshift -DNS. The DNS pod is running over here. You can see the default DNS pod, and this is controlled through the DNS operator. So you can see the DNS operator over in this project, Openshift DNS -operator. So that is a project. The operator for this project is inside this, running inside this. The application is running inside this project. So we are just identifying these components, which is, as I told you, this is running. So this is responsible for doing all these things. Now we'll get back to our project, which is my demo 4, and I'm going to create a route for this. So I'll get to the project, OC project my demo 4. So here, if I do OC get pods, you can see the pods running here. So I'm going to create a route for this. So initially I don't have a route. So if I do OC get route, so there is no route in this project. So I'm going to generate a route. So generating a route is very simple. So, but you have to understand what is happening at the background. So that I explain these things. So, but to generate it, just it's a one single line command. Once you expose this service, automatically you have the route in place. So you do something like OC expose. So we're going to expose the service of this one. So there you can get the name of the service by using OC get service. I'm going to expose this service. This service already has a default DNS entry. So whenever the service is created, that entry will be there. The entry will come into the picture only when you expose it. So when you don't expose it, the entry will be passive. So only when you expose it, that entry will be active. So that you can able to do that, get that application. So that is one way. Simply, if you expose it, you get the route. Another one is you can get the host name. You can give your own host name, provided this host name, whatever you're giving here, doesn't conflict with the cluster other application. If there are two applications which is having the same host name, then it will be a conflict. So you should not use that same host name for different application. So if there is no conflict, you can generate your own host name. You can generate your own DNS entry. But if you don't do that, it will automatically we have a DNS entry available there. So for that service. So if I do OC expose, so service, name of the service, the name of the service will be my app. So I'm simply exposing the service. I got a route. If I do OC get route, you can see I got the URL. So this is the URL. Now I can, if I do the OC describe route, OC describe route, or you can see, I just use OC get route. So I'm going to describe this route. OC describe route. The route name is also my app. I'm describing this route. Here you can see now all the layers which we are discussing so far. So here you are going to see, starting from the route layer, underneath the route layer you will see the service. Underneath the service you will see the endpoints, which is the application, which is the endpoints over here. So you can see all the details to reach this application from the route to the service and the endpoint. So when I describe the service, here you can see the request host, this URL. If you take a look at this, if you dissect that URL, you can see the my app is the name of the service. So here you can see the service name, which is my app, hyphen followed by the project name and followed by the cluster domain. So this together is a cluster domain. So in this fashion, it is creating that this is just already have this entry. When you expose it, you will get the route URL in this fashion. So you will see that here. So you can see this is exposed on the router default, and the router default, as I told, it is running on this project, which is Openshift-ingress. So on this project, it is running. You can see this router default is running on this project. So you can see this is exposed on the router default. So the host name of that is the host URL of that router will be this one. And below that you can see the service. So this route is resolved to this service, linked to this service. Below the service I have the endpoint. So you can see the endpoints. There are 3 more endpoints. So you can see the endpoints. So now you can see the overall picture. So you can see from here. So when the client reaches, he will reach this router. The router will already have a route. So it has admitted this URL. It is exposed on this router. It has entry for this. So you can look into that. You can just use OC get route. You can use the name of the route is my app and c-o YAML. You can see the definition of the route file. There you can see the current status. The condition, you can see the type is this is admitted. So this is admitted on the this host is admitted on the router. The router name is default. It is admitted over here. So we have entry in the router, and once the client reaches this router, this entry will be resolved to the route, and the route will be resolved to the service, and service will know where to redirect the request to the pod, and the service will underneath this thing will do the load balancing. So it's going to do the load balancing work. So we'll see now the overall picture. Now, as of our lab scenario, so now I can communicate using that route URL. Now I can communicate to the cluster from the workstation itself, because this is now a publicly resolvable DNS entry. So using that, I can able to communicate from the workstation, or I can even communicate from the utility. So because this is also in the same network, I can use this to communicate to this. So we can look into that now. So I have the route here. So we see get route. So I have the route URL. So I can curl this. I can do a curl with this URL. Now you can see I'm reaching the application. So I'll curl 1 or 2 times. You may see the load balancing. Now you can see the load balancing is happening. You can see that. So first it's redirecting the request to the pod. 2 times it is redirecting to the same pod. 3rd time it is redirecting to the different pod. You can see it is redirecting because I have only 3 pods running, so it will load balance among these 3 pods. So now I can reach it external. Now I can reach it from the workstation itself, or I can even reach it from the utility machine. It's using the same URL because which is in the same network. Can use it. But in the real-time case, it will be a public resolvable DNS entry, so I can reach it from anywhere. So I can just do a curl. Then I can reach it even from the utility machine. And internally, everything is happening. So internally, the load service is rolling the load balancing, and the application is running inside with a particular IP address. So now we started with the different things. Now, when you are doing the troubleshooting, you have to remember this model. So this is very essential thing. So anything can go wrong in anywhere. So now you have an idea. So where the things can go wrong. So like sometimes the things can go wrong on the route layer, maybe at the service layer. Maybe in the service layer, some labels may be mismatching. So it's because of that service may be disconnected from the pod. So the service may not have endpoints, or the application layer itself you have some issues. So the issue may be in the scheduler, or issue may be in the image, or issue may be in the issue may be in the particular SDNs or like that. So the issue may be anywhere here. So you have to remember how the flow is happening. So in each layer, what are the components responsible for doing each thing, starting from deploying the application. What are the mechanisms are happening? So what are the events are taking place? So starting from when you execute that deployment command. So what are the events are taking place? So how the IP address is getting assigned? Which component is responsible for creating that IP address or provisioning that IP address? And which component is responsible for provisioning that interface? And what is the purpose of service? How to create a service? How to select? How a service can select a pod? So these things are essential to know about the networking. This is the main flow of networking. So when you troubleshoot, you have to remember this model. So with that, we cover up this section of the 5th chapter. We have just, so far we are in the first section, which is like I told you, it will be lengthier because they have to learn a lot of concepts. They have learned about the networking model. So we have learned about the service, and we have learned about the DNS operator. What is the purpose of DNS operator? How the DNS operator creates service record. Then we have learned about network operator. So what is the purpose of network operator? Then you have learned about multas. So the CNS, which is responsible for providing the Ethernet interface to the application, so the pod which you are creating. So that we complete this session. So there are some references to learn more about different things. There is a guided lab. So here you can do the guided lab. The guided lab before that, okay, let me before you go for the guided lab, so let me build an application which is there. So let me build a real-time application and see how this, whatever the network things, network components we have learned, how to utilize this for just deploying a real-time application. So we'll create a real-time application and we'll see that. So here, any application stack. So we called it as an application stack, like any distributed application. We have the 3 different layers to an application. The first layer will be the front-end layer, or you can say front-end interface. There will be a front-end layer. Then we have the business processing layer. So the business processing layer is responsible for the client who is accessing it. For example, if you take the Facebook. So once you are accessing the Facebook, the front-end page, you will provide your login credentials. So that front page is same for all. So where I'm going to provide the login credential, that will be the same for all. Once I logged in, then the pages differ. So for me, my Facebook page will be different than your Facebook page, right? So you will have different news feeds, you have different friends requests, and you will say the different friends details, and myself will be different. So that is what the business processing layer is. The business processing layer, which is specific to a customer. So specific to a customer, it's going to display the things, which is not same for all. So it differs. So that's the business processing layer. So that is, according to some business logic, is going to generate some pages. You can write the business logic in PHP, or you can write it in Python, or you can write it in Java. So you can write that business processing layer. That is one of the components of any application stack. Then finally you have the data layer. So I can say data store layer, or you can say database layer. So the purpose of the data store layer, or you can say is to store the data. Like it is need to provide the persistent data, so that when there is a, for example, I'm doing a login into the server, so the user login credential need to be stored in some way, so that when the user is logging again, so that the credential will be retrieved and checked against the password, and if it is matching, then it can allow that user to access the server. So there I need to find a mean to store that. So that will be the data store. And together, this business processing layer and the database, we call this as a backend layer. So we can say backend. So this is what the entire application stack is all about. So having known about this, now we'll build a application where we are going to see this front and back end, how this things together. We are going to build an application called integrated application. The integrated application will be in distributed nature, like it will have a front end and the back end. So both will be connected together. So we're going to see that. So we'll use the same example which we have generated in the morning. So here I'm going to create a project. So in this project, so already we deployed that application. So we have one application like so this application has got some service. So this is the this is so let me say this is the front end and the back end. So I'm not having the business processing layer. So here just I'm going to have the front end and the back end. So the front end will be the WordPress. The back end will be the MySQL. So we're going to see how to integrate it. So here my front end will be the WordPress application. So this is the WordPress service. The WordPress service. So here it is MySQL, and this is the MySQL service. So this is my front end. And this is my back end. So the business processing layer actually included in this front end itself. So as a part of this front end, the business processing layer is included here itself. Sometimes the business processing layer may be a separate one. So in that case, you have to integrate that thing also together. Okay. Now what I will do is I will create a route. So I need to create a route for this front end. I'll create a route. So through that route, I'll reach that front end. Let me say this is the route which I'm going to create. So this route will be resolved to this. This will reach the service. Through the service, I'll reach the application. As a client, I will reach this route. The client, I will be reaching this. So say my job is to create a website. So build a website for a client and hand over this website to the client, and the client will access that website page, or the client will give that website to his clients or his customers so that they will access this web page. So this is my job, this is my task. So I'm going to run this task or run this thing in a containerized way. So I'm going to containerize the WordPress application. I have already containerized the MySQL. So I'm going to connect the WordPress and the MySQL together, so that it will act as a single application, or you can say integrated application. Okay, before I do that, before you do any integrated application, if you're going to do that, what you're going to do, you have to check the communication between these two applications. So internally, I have to verify whether this application is able to communicate to this. And similarly, so from here to here. So this is what we call as internal functional network testing. So this should be able to communicate, this application should be able to communicate to this application through this service. Similarly, this application should be able to communicate to this one through this service. Then only I can properly integrate this application at the front end level. So this is what we call this as a functional network testing, or you can say internal functional network testing. In the real time, you are going to do this testing once before you go and integrate this application as a single unit before you hand over to the client. So you will perform this testing, and once it's fine, then you will go and do the integration. Now we'll see already we have deployed this application, so I'm not going to deploy the application. Already we did other implementation. We have already deployed that application. I go to this project, OC project, my demo 3. So here already this application is running. When I do git pods, you can see this application is running. And actually this is not I think Postgres is not required. Let me now delete this one. So I just required the MySQL and WordPress. Just deleting this. That we have only. I'm ready. So now I have all the services also created for this. Since I use the ocnap command, the services created for this two application. Now I need to verify these things. So before integrating it, I need to verify. What I will do is I will get into this MySQL application. From here, I will try to communicate to the WordPress through the service, not directly, through the service. Directly also can communicate, but through the service, that is what I require. And also this WordPress application is going to communicate to the MySQL through the MySQL service. So I want to verify that. So I'll go to that. I'll do OC RSH. I'll go to the MySQL. Get into the MySQL. Here I'm going to do a curl. So I add a verbosity -b. I'm going to use this IP from the I need to use the WordPress cluster IP. I need to use this service IP because I'm going through the service. So I'm going to reach this service and I'm reaching the application. So I have to mention the service IP here. Then the port number. The port number for this WordPress is 80. This is a port number. I'm just reaching it. So I should say the connected message. So I'm not reaching that application because the nature of the applications are different. But what I'm doing is I should see the connection message. So here you can see connected to. So that means the application is able to communicate to this. Through the service I'm able to communicate to that application. So that is fine. So this way now it works. Like this red line works now. I want to do it the other way. So now this blue line, I want to get inside the WordPress. From the WordPress I want to communicate to the MySQL and see whether the application works, whether it is reaching or not. So in this case it will reach. So we'll just verify that. We'll get the service name. So I'm going to get into the pod OC RSH. I'm going to get into the WordPress pod. So from here I'm going to do a curl -b. I'm going to use this. Now I have to use the cluster IP of the MySQL service. I have to use this now. I have to use the port. Port is now 3306. I have to use this service port to reach that application. 3306. I have to use that. And I should see now also it is connected. So I don't have an issue. Now it is connected to this port. So both the ways now it works. And whenever you are doing a testing, it's always a good idea to falsify your result. So falsify in a sense, whatever testing you are doing, you better like you do it in a reverse way. Like you mandatorily or you can say deliberately you make some mistakes and see that it is not working. Then you restore that back and see that now it should normally work. So you will do some falsification testing. So here I'm going to do that falsification testing here. So what I'm going to do is I'm going to remove this connection from this. So this service is not going to get connected to the application. I'm going to remove this connection. After removing it, I'm going to do the same testing again. In that case, the testing will fail. So this is what a falsification test. So I'm going to falsify my result so that I can be sure that the communication is happening because of this components. So to make it sure, I'm just going to perform these things. So how to disconnect this service from this? So to disconnect this, I have to change the label selector. So now if you do OC describe service, so when you describe the service, name of the service which is WordPress. So here if you grep for the selector, so we're going to see selector. We grep for the selector, you can see the selector condition here. So this will be always matching with the pod. So if you look at the pod label, OC get pod, the name of the pod is WordPress. So here we grep the label, look for the label. if you look into the label, you can see that these two things are matching. So that's the reason why I have the endpoint. If you do this OC describe service, so here if you look into the endpoint, the endpoint will be available. So now everything is connected. So because the service is able to select this pod, and so that we have the endpoint open. So if I change this label, if I edit this service and change this label, and it will get a mismatch now. And what happens is, once it is mismatched, so this service will not able to choose this pod because it is going to look for the pod with that label that is not available. So here you will see the endpoint will be gone. So once this endpoint is gone, so we will achieve this condition where the service will be hanging without the endpoint. So we'll achieve this condition. Then we'll go and do this testing, and this testing will, in that case, it will fail. So now after that we'll restore it back again, then we'll do the testing again, then it should work. So this is what a falsification test. You can do that reverse way also. You can remove this connection and you can try it out this way. So I'm just doing it in one. So once it's working, you can try it. Once you are trying, you can try this in the other way. Okay. So here I'll do that same. Now I'll go and edit the service. So we'll see edit service. The name of the service, which is WordPress. I'm editing the service. So I just go to the selector. So here I deliberately introduce an error. So I just make it like WordPress. I'm going to label it as WordPress 123. Randomly, I'm just saving this file. So once now the service is edited, now you see the label will be changed. So now you can see the label is WordPress 123, like deployment equal to WordPress 123. Now we check the label of the pod, that will remain as it is. That is WordPress. Deployment is equal to WordPress. Now there is a mismatch. Because of this, now you will see the endpoint will not be available. So when I do OC describe service, when I try to check the endpoint, you see that endpoint is gone. So there is no endpoint. Previously the endpoint was there. Now the endpoint is gone. That means now I achieve this condition. So this service is not connected to this pod. And now if I do the testing, so previously when I do this MySQL to this, when I do the testing, so you see that it was working. So when I get into the MySQL and I try to connect this, when I do this curl and try to connect this, so this connection was working. I was able to see the connected message. Now I'm going to do the same testing. I'll get into this same application. I'll do the same testing now. You'll see now testing will fail. So I go here, I do a curl, so with the same IP address. So if I do a curl now, you will see that now it's hanging. Now you can see it is trying to connect to this one, but it is hanging because the service is not having any pod underneath it. So there is no endpoint. The request reaches the service and the request stops there. It is hanging there because it doesn't have any endpoint. That's why we call the endpoint should be there to terminate my connection. So the endpoint is not there. It will be hanging over there. So now this connection, this is failing. So now we have falsified a result. So we have make sure that the communication was happening because of that. So now we have falsified the result. Now let me exit out of this. Now I want to restore it back. So now I don't have the endpoint. So I want to restore back the endpoint. So how to do that? Just match that label correctly so that you will have the endpoint again back. So this kind of troubleshooting you will face in the real-time scenarios. So where that service labels may go, like it may be having some mismatches. So you have to see that it's having a correct label. Then only the service will have the endpoint connected to it. So here I'll go back again and I'll just change this label. So I'll restore it back to WordPress. Save the file. Now if I describe the endpoint, now you can see the endpoint is back because now the labels are matching. You can see that now both the labels are matching. As a result of that, you are having the endpoint. Both the selector as well as the pod labels are matching. Now the endpoint is back. And now if I do the testing, now if I just go to the, I'll repeat the testing again. Now this testing is go to pass. I do a curl again. You can see now it is connected. You can see the connected message. So now I have restored this back. So now I'm restoring this condition back. Now internally this applications are fine. So I need to now integrate it. So what I'm going to do is externally, I'm going to connect or integrate this application together. So this one and this one, I'm going to integrate it together so that it works as a single application. So if you look into the WordPress, WordPress is an integrated application. So internally it has a PHP which takes care of the business logic. So we have Apache server running inside, and at the backend we have MySQL server which is going to store the data. So we need to have a backend for this. Without the backend, I cannot deploy this application, or I cannot deploy this application for the client. So the application may be running, but if I want the real-time scenario, I want to deploy this as an application so that the client can start using it. In that case, I should provide the backend to it so that it's going to store the information about the site. So now we'll start the integration process. So what I will do is now I need to create a route. So as per this lab scenario, so I'll be creating a route. Here I'm going to give a host name for this route and I'm going to create it. I'm going to call this as WordPress. So WordPress dot this is my domain name, apps.ocp 4.example.com, my domain name. So I'm going to create a route. So once I create this route, as a client I will access it, access the application through this route. And also I need some information about this MySQL service. So I need to know about the name of the name of the user, name of the database, so which I need to provide as input to this WordPress. So I need to provide that information. So I need to collect that information also. So I'll plug these things. So here I need to create a route. So I have the service. For this service, we'll create a route. So see expose. So I'm going to expose the service. The name of the service is WordPress. So here I'm going to expose with a host name. So here I'm going to create my own DNS entry. I'm going to say WordPress dot apps. Even when you are exposing the application with your own host name, the domain name should be same. The domain name you cannot give your own domain name. The domain name should match the cluster domain. Here in this case, it should be apps.ocp4.example.com. So I'm creating the route. So now we got the URL. So we get route. You can see the route now got created. Now I can reach this one to this route. I'll reach this application. So I need to create the route for the front end only. No need to create for the backend. Backend is just going to act as it's going to get integrated with the front end. So no need to provide the, because backend as a user, as a client, I'm not going to access the backend. I'm always going to access the front end. And I need to fetch some information. So for integration, so I need to fetch the information about the MySQL. So I just get into that application, MySQL pod. So here I'll try to log into the MySQL server using this. I think I was creating the user with the name Rocky, the password Red Hat. So here I want to show database. So here you can see the database. So I want to use this information. So when I'm going to integrate it, it's going to ask for the username, it's going to ask for the password. So I just make sure that I have this thing ready. And also I will provide this cluster IP, so internal IP as a host name. So if it is a physical server, actually I'll provide the physical IP address. But here it is running as a containerized service. So containerized application will have a cluster IP. So I have to provision this cluster IP for the integration. So now I'll go back to I'll open up the browser in my client machine. Here I open the activities. Here I'll open the Firefox. So once I open the Firefox, I'll use this URL to reach that application. then there are a few steps you have to do to configure that application. So here I'll open the Firefox. Here I have to use that route URL which I have created. So the URL is this one. Here WordPress. I'll copy this URL and go here. Paste this URL here. Now I can see that I get into the WordPress installation page. It's going to ask for me to select the language. I'll select the language. Then after selecting that, it is going to ask for the information, like it's going to ask for now. So it's saying that welcome to WordPress. Before getting started, it's asking we need some information on the database. You need to know this information, know the following items before proceeding. So we already collected this information. Now the database name is MySQL_DB. So we already collected this information here. So the database name will be this one, is here, MySQL_DB. This is the database name which I'm going to give. And the username will be this one, Rocky. The password will be Red Hat. And the host name, the host IP address will be this one. So I have all this information ready over here. So database name, username, password, host name, and all these things. I'll go to the next step. I'll just click this, let's go. It will take you to the next steps. Here I have to give the database name. The database already created, the empty database, which is MySQL_DB. My_DB, sorry. Then the username, I have created the username as Rocky. Then the password, which is Red Hat. Then I have to provide the host domain. So here the host domain, the physical IP address. So here I have to provide the cluster IP address. I will copy this. Right. So table prefix I just leave it as it is. That will be WP underscore. That will be fine. Now I will submit this information. So once I submit this information, so what happens is it will do the testing. It is going to try to communicate here. So what it will do is the WordPress will internally inside this project, it will try to communicate to this service. It will reach the service because I am providing the IP address of that service. It will reach the service. So after reaching the service, it will reach the application. So it is going to reach it. So if it is not able to reach here in this step, you will not able to configure the application. So here I'll try this. Now I'll try to submit this. Then it will see it is going to reach it. So now I can see all the things are right. So you can see the message. You made it through the part of installation. The WordPress can now communicate with your database. So this is very essential. So without the database, I cannot install the WordPress. So now I can start the installation. I can run the installation. So it will take you to the next step. So here I need to provide some information related to the site. So which we are going to create. So I'm going to create a site called, I'm going to name that site as DO280. So here the username, I'm going to give some random username, Sam, some password. So I'm going to provide some email ID. From the weak password. So here I will start then the WordPress installation. So now the installation will happen. Now you can see the installation is success. Now WordPress has been installed, and you can see the message. Thank you and enjoy. You can. Now I can log in as this user, Sam, and I can with the password I can log into this page. Now you can see the application is ready. So now I can customize the page. I can customize the site before handing over this site to the client. I can do the customization. So this is what the WordPress you can do. You can create your own theme. So you can have your own pages and all these things. So you can customize this. You can place some background images of your choice. You can select some images, and you can build your website. So you can add some additional CSS pages and all these things. So once you are ready, so you can publish this site. So once you publish this site, so this site will be ready. So now it is published. Now I just close this browser. So as a client, I can now view this web page. So I'll just close this site. So I just open that now again, the same site. So I customized it and I published that site. Now as a client, I can access that page. And now we can see the entire application, which is containerized. So the front end is containerized, the back end is containerized, is running inside the OpenShift cluster, and the client is able to reach that application. So you can think of any application you can containerize, any web application you can containerize it, so that client can reach it. And the client will not know where the application is running, but the client, the client is just use that URL and he will just able to reach that application. So now you can see the WordPress page. You can see that the page which we have customized. The client, consider this is a site, so this is any site you can think of. So now the client can reach the site and they can read the information. So at the backend, what happened is we have deployed that, we have containerized the application, we have containerized the WordPress. And if you look at from the starting, you can see the WordPress was running as a root container. The SEC was not preventing, SEC was preventing that. Then we have changed it. Then we have deployed the MySQL. For the MySQL, we created the information as a secret. So everything together, we made it as a one compact application. So this is what a integrated application. We have the front end, back end, which is running inside there. So this is a base for something like a microservice. So we can have multiple services like this. You can integrate them together to act like a single application, the single integrated application. Okay, so with that, we come to the end of this session. So there is a lab. So you can try this lab. In the lab, you are going to build a similar application like this. Here, you are going to build the backend. The backend will be MySQL. So here you are going to use the declarative architecture. So you will have the file. So once you run the lab setup command over this lab, you have the file. So you have the files over here. So using that file, you will deploy the front end, the back end, some databases will be there, some data you have to copy it. So you will do that and you will run that application. You will deploy the front end and the back end. So after deploying the front end and the back end, you create the route and everything. Once you try to reach it, so what happens, the application will not be reachable. So you will get this message like application is not available. You have to troubleshoot it. So that is the part of this lab. So since this lab, this section is about troubleshooting, so you have to do a troubleshooting. So what will be the problem here over here? The problem will be in the service. So service, there will be a label mismatch. So there will be no endpoint available. So when you try to see that service, you will see that the endpoint will not be available. So the endpoint will not be there. So you have to see why the endpoint is not available. So what label you have to match it. So they have given the steps. You follow that steps to rectify this issue. Once the application, once you correct that error, once the endpoint is back, then you can see once you reload that page, you will see that application. You will see this to-do list application. You'll be able to see that. So here they use the to-do application. So I have used the example of WordPress. So you can use that just for your implementation part. I use the WordPress application. Here they use the to-do application. You can build this application in C, and you are going to do a one troubleshooting kind of thing. So I didn't do any troubleshooting because I did that as a part of a functional testing. So you can find how that worked. So how I did it, I just tried to communicate internally. So then I falsified my own result. So by just removing the connection, then again I brought that back to connection. Then I took it to the testing. That was working fine. Then I went outside and created that integrated application. So I integrated the front and the back end together. So with that, we complete the first section of the 5th chapter. Then we proceed to the next section. So we can complete the lab. Now the time is almost 4 o'clock. So we will start back around 4:20. So we'll start around 4:25. We'll start the next session. So any doubts so far? So this is very important. The networking part is very important. So as the administrator, you are always going to some way or other you are going to deal with the networking. So please understand. So that's why I took some time to explain these concepts, because this is very foundational concepts. So once you are embarking on the OpenShift career, or if you're on the DevOps side, or if you're on Kubernetes side, the networking is the core. So you have to understand the networking component. So based on that, you're going to build the other things. So if you are strong in the foundational things, other things will be easy to understand. So that's why I took some time and I built one real-time application to emphasize more on that concept. And that was a build process. I was not directly building that application. I deployed that application as part of other lab installation. Then here we just integrated that together. So we learned about the secret concept, we learned about the security concept, the SEC concept. Then here we learned about the networking concept. Together we made it one single integrated application. So any doubts, we can discuss it. So this is very important, even from the exam perspective, is very important. So we will start back the next section by 4:25. So 4:25 Indian time, 4:25 p.m. So if you have any doubts during the lab practice session, just put in the chat. I'll see that.